Hi, and welcome to episode number 74 of the weekly Google Cloud Platform podcast. I am Francesc Campoy, and I'm here with my colleague, Mark Mandel. Hey, Mark, how are you doing?
I'm good. I am back in San Francisco after a little trek over the East Coast, but it's good to be home. How are you doing?
Very good. Back from a little trip to China, and indeed, it is very nice to be home. I am very happy because today we have, again, someone else from our team. We have Sara Robinson to talk about, I think it's probably the latest API.
The Cloud Vision Intelligence API. It just sounds smart. I like the sound of it.
Yeah, it is. It is really cool. There was a really cool demo. We talked with her during Cloud Next on day one. I think she did an amazing demo. We had a quick chat about it, and she's back to tell us even more. So very excited.
Yep, and super excited to hear that. After that, we have our question of the week, where we will be talking about backup strategies for persistent disks.
Yeah, you want to make sure that whatever happens to your machine, the information is not lost. So how do you do that? And yeah, we'll be talking a little bit about multiple options and pricing and stuff like that.
Excellent. So why don't we get stuck into our cool things of the week?
Yep.
Cool. So to start that off, we talked last week a little bit about the Cloud Identity Aware Proxy, basically being able to lock down your applications using identity at a network level. There's a new article that's come out recently talking about how basically to get started with it and how you can use it within your own applications.
I think it's pretty good because last week we talked about it from a very high level point of view. And this one is really like, oh, so you're really interested? This is how to do it. So if you're actually interested in improving the security of your network, dropping VPN, instead using basically identity, so SSH certificates and stuff like that, go check it out. There will be a link on the show notes as always.
Yeah, it's pretty neat. It takes you through several different authentication options from like OpenID and IAM and a few other ones as well, so that you can pick and choose the one that works right for you.
Yeah, and then we have another cool thing of the week that is very, very cool, especially because it's about Go this time. So yeah, our coworker, Jana Dogan, wrote an amazing article. She is very well known in the Go community. She may be known also as Raquel, which is her GitHub name. And she wrote about how to do distributed tracing in Go, which is kind of a hard thing to do. So we've been working on it lately, and she wrote a very good article explaining what are the techniques to be used, how to use it, and even open source the little library that allows you to use Trace ID and send it around different servers, all of that powered by the context package. So it's a very interesting blog post, especially if you write Go. If you don't write Go, what are you doing with your life? Now, if you don't write Go, it is still a very interesting one. Because there's all the distributed tracing, all the problems that are attached to it. So it's definitely worth a read.
Yeah, and it's super cool to see that it has direct integration right with Stackdriver as well. So you can see all your distributed traces, how long they took, all that sort of good stuff too. So you can see if there's one particular part of your microservice infrastructure breaking something in some way.
And then the third cool thing of the week, it's a very interesting one because I have no idea what it is, other than it is the largest compute engine job ever run, which is 220,000 cores. And those cores are actually preemptible VMs, which I guess makes sense because when you're running 220,000 cores, the fact that you can get them for less money makes a lot of sense.
Yeah, I would have loved to have seen the quota increase request for this.
It's like, yeah, I'd like to run a little server. Only 200,000 cores.
Yeah. It's gonna be fine. Everything's gonna be fine. What was he calculating?
So I'm gonna read this with, it's like I could be reading some other language that I don't understand and it would sound the same. So he explored 10 to the 17 hyperelliptic curves of genus 3 in an effort to find curves whose L functions can be easily computed and which have potentially interesting Sato-Tate distributions.
Oh, of course, clearly.
Yeah, there you go. So there's cool diagrams. It's like, that's pretty much what I can say. But basically, this is definitely heavy computation going on. And it is pretty amazing to see that they were able to just run it and using VMs and everything is, I was going to say everything is simple. The infrastructure itself is pretty simple.
The maths
what
might
they're
be a little
doing,
hard.
the math behind, I have no idea. But yeah, if someone knows what this actually means and they can explain it in a sentence, please let us know. Because
Yeah,
I
we
really
would
don't
love
know.
to. Send us an audio transcription and we'll put it on the podcast.
Yeah, that'd be nice.
Awesome. Well, why don't we go have a chat with our good friend Sarah all about the Cloud Video Intelligence API.
Sounds good. Let's do that. I am very happy to welcome back Sara Robinson to the Google Cloud Platform podcast. Hello, Sara. How are you doing?
Hi, Francesc. I'm doing well. Excited to be back on the podcast.
Yeah, very happy to have you back for a second or third time. We're going to be talking about some cool demos that you did at Google Cloud Next during the keynote of day 2 or 3. But before that, why don't you tell us a little bit about who you are for those that have not seen any of the many, many episodes and talks that you've given before?
Sure. My name is Sara Robinson. I'm a developer advocate with Mark and Francesc on the Google Cloud Platform team. And as a developer advocate, we do a combination of building demos, giving talks to show developers how to use different cloud products, writing blog posts and bringing that feedback back to the product team. And I'm focusing primarily on machine learning APIs and some of our big data offerings.
Cool. And you were on stage for keynote. What was it, day 1?
It was day 1, yes.
Yeah. So, and you did an amazing demo. But basically, everyone told us that was by far their favorite part of the whole day. So, why don't you tell us a little bit about what was it about it?
Sure. I built a demo to showcase the Video Intelligence API, which we announced in private beta on day 1 of Cloud Next a couple weeks ago. And what the Video Intelligence API does is it gives you metadata on videos, makes it really easy to search video content. And with the demo, I wanted to show that off. So what the demo was I took a lot of videos and ran them through the Video API. And the demo let you visualize all the labels it found in a video. So it's able to tell you there's a dog in the video, starts at second 1, ends at second 3. So on the page for an individual video, you'd be able to see all the granular data on what different labels it found at which points in the video. And then with all that metadata from the API, you're also able to easily implement search across a large library of videos. So I showed how you could search the library of videos that I had. A lot of the videos were from the Google YouTube channel. So I did a search of baseball videos. So I wanted to be able to show what a large media company might be able to do with the API. Let's say they had hours and hours of video footage sitting in storage buckets, and maybe they're a sports media company that has hours of sports video, but they only want to find the content with a baseball field in it. Maybe they're creating some sort of sizzle reel at the end of the week to highlight specifically baseball content. So if you were to do this manually, you'd have to have someone on your team go through all those hours of footage, watch the video, write down the times when all the baseball clips appeared. With the Video API, with all of the metadata you get back, you can pretty easily implement search because you're just searching the JSON that's returned from the API. And it'll tell you not only which videos have exactly what you're looking for, but when in the videos your search term appears. So the demo was essentially built to showcase those 2 features.
Nice. So could you tell us a little bit more about what does it do exactly? Because when you tell us about, it's able to see things, like it's able to recognize a baseball stadium, I directly think about the Cloud Vision API. But when you say when in the clip, it makes me feel about like speech API that recognizes like over time. Like where does this fit in between?
Exactly. That's a good question. So right now it doesn't do anything with audio yet, but people might see the API and think, well, isn't this just the Vision API taking a frame and analyzing it and then aggregating that content? So it does do that. The Video API samples images at 1 frame per second, and it uses an image classifier that's similar to the Vision API, and it does this for every scene in the video. But the core of the Video API, the real magic behind it, is that when they're done processing a video, taking all the frames, they have a separate video aggregation classifier, and then this will analyze all the features throughout the video. And then at a high level, it'll be able to tell you what is this video about. So let's say you had a video of costumes and candy. It could tell you that this is a video about Halloween. So that aggregation classifier is really like the secret sauce of the Video API. And to build it, they trained this model on many YouTube videos to be able to do that.
Cool. When you said a video with customs and candy, actually I thought about Katy Perry, but that's me.
That works too. I don't know if the model's ready to detect that yet.
So if you have like 1 frame per second and you're analyzing all of those, there's a bunch of the frames that are pretty much the same, right? But all of a sudden, like there also changes, like you go from seeing a house to seeing, I don't know, like a shark dancing or whatever. Is there something related to that it can allow you to understand the structure of the video?
Yeah, definitely. There's a feature called shot change detection. And what this does is it's able to detect every scene change in a video. So as you said, like let's say you have a vacation video and you're panning to some mountains and then you move it around to show some people jumping up and down. It's able to detect whenever the scene changes. And if you request shot change detection in the annotation types that you want back, it'll tell you, essentially give you a JSON object of the start and end time for every different scene change throughout your video. So you can do this to create, maybe like a highlight reel of your own video so that you know exactly which points in the video the scene changed.
Okay, cool. So you mentioned something in the previous comment you made, which made me think of the Vision API as well, which was that it sounds like you can pick and choose which features the video API actually goes and finds within it. Like I know with the Vision API, you can choose like sort of emotion recognition or possibly location. It sounds like with the video API, you can also do something similar there too.
Mm-hmm. Yeah, right now there is label detection and shot change detection, but there is definitely more in the works coming soon.
Nice. So what are the things that you can build with this? Because one of the things that I was imagining is, imagine that you have a very long video, right? And you're like, oh, I remember that like I was watching this video and the last thing I saw was that scene where you can see, I don't know, like a train. So you could say, hey, go to the scene that has a train. Would that just work? Like, is that something that people are building?
Yeah, I think the biggest use case for this is searching videos. Movie navigation, like you just brought up, is also a good point, which is related to search. So because you get metadata on what's happening in every scene, it's pretty easy to build an app that will go to specific scenes throughout the video. And say you want to use the shot change detection to show the frame at each point in time, and then go to a certain frame based on that image or a specific search term. So navigation is definitely one, navigating throughout a movie. And the biggest use case I see is searching large libraries of video content. So a lot of sites have a way for users to upload images and video, or media companies could have lots of video content sitting around that they need to analyze, or maybe they don't have any search implemented on it right now and want to add search functionality to it. And I can actually talk about 2 companies that have been using the API to implement something like this. So the first one is called Cantemo, and they're a media asset management company. And what they do, their customers are anyone with a lot of video content. Could be an individual or a company that has a lot of videos. And they make it easy to essentially manage your video library. So when you upload a video to their service, they'll transcode it for you. And they're using the video API to improve their search. So this way they can make it so customers can easily search for, like you said, find all my videos with a train, and it'll know exactly which point in the video that occurs. So that's one example of a media company using the video API. Another company is Wix, and Wix is a service, for those of you that don't know, that lets anybody create a website, and you don't have to be a developer to be able to create a website on Wix. And they're using the video API for what they call Wix Media Platform, which is a platform that they use to support users that are uploading a lot of images and video files every day. So when a user uploads a video, or say like someone's building a website and one of their users uploads a video, the Wix Media Platform will transcode it, and then they'll use the video API along with shot change detection. So they use both shot change detection and label detection to grab the main images from the video so that they can show users kind of the highlights of what is this video about. And then they also use the metadata returned to add tags to their videos. And then with this, they're also able to add search. So if they've got a website that has a lot of user video content, it makes it easy for users to search both within a video and an entire library of videos.
Cool. I was wondering if there's some of the features that we've seen and we've used on Cloud Vision API, if those are available in Cloud Video Intelligence API. Specifically, I'm thinking about that amazing demo that we had at Google I/O and at, I think, GCP Next too, which was the Emoto booth. Mm-hmm. Do you remember that it was like takes a picture of you and according to the reaction of your face, the feeling, like if you're smiling or you have anger, it makes the background a little bit different. And I was wondering if the Cloud Video Intelligence API allows you to do things like, hey, find me all the faces in a video or find a face that is smiling, this kind of things. Is this something that is already supported?
Yeah, right now only label detection is supported, but that's definitely something we've gotten a lot of feedback on. And the team is working on adding more of those features into the video API. So one thing that was really popular with the Vision API is the inappropriate content detection. So you pass it an image, it's able to tell you, is this image appropriate or not, which eliminates the need for a lot of manual classification on images if you've got a site where users are uploading a ton of images every day. Instead of having somebody manually flag those images, you can use the Vision API's safe search detection method to do that. That is something that obviously has a big use case for videos as well, and we're working on adding more features to it soon.
I mean, I guess that for any of those, you could also just like use the shot frame detection and go find one of the frames and use that as the input to the Cloud Vision API and play with that. Is that something that you've tried?
I haven't tried that personally, but that's definitely something you could do right now. So if there was a specific label that was returned from your video, you would know exactly which frame to go to. So you could grab that frame. The times it returns are in microseconds. So you could grab that exact frame that you wanted, send it to the Vision API to run, maybe face detection or safe search detection on it to get more data on your video.
I've been thinking about trying to run it through security cam footage, so the stuff outside my house. It'd be like, show me all the times there's a person sitting at my front doorstep.
That'd be a great use case. And the API right now can probably recognize, that there's a person in the scene. But if you find the scene that has a person in it, you could go ahead and send that to the Vision API to get more data on, is this person happy or angry or surprised?
Or maybe catch the coyotes that have been roaming my neighborhood recently.
Catch the coyotes, yeah.
Exactly.
San Francisco.
Figure out exactly what times they go by your house.
Cool. So let's talk about the technology behind this. Can you talk a bit about, I know you mentioned the YouTube dataset, but can you talk about what's powering this? Is this another TensorFlow project?
So there's a couple models powering it. So they use the YouTube videos to train their video aggregation classifier. And then it samples images, I mentioned before, at 1 frame per second. And to do this, it's using a custom image classifier, which is similar to the Vision API, but a little bit different. And that's what it's using to go through the video and grab an image from every scene.
Cool. So one of the things that I really like about these kind of APIs, like specifically Cloud Vision API and now Video Intelligence API, but also like Speech API, is that you can start building really cool demos that are very interactive. So I feel like lots of people that are not necessarily deeply technical, they could take some benefits out of this and create very artsy demos. Is this easy to use? How does it work?
Definitely. Yeah, it's very easy to use. And one thing that I love about our machine learning APIs is that they give you access to a pre-trained machine learning model with just one REST API request. So I call them our friendly machine learning. If you don't have much of a machine learning or data science background, these are really accessible. All you need to know how to do is make a REST API request, and you get access to all of this machine learning data. So the video API is very easy to use. All you need to do is pass it the URL of your video in Google Cloud Storage, which is our object storage tool. So right now, that's what's supported for making a request. So once you get your video in Cloud Storage, you send that video URL in your API request. You also tell it which types of detection you want to do. Right now, you could do either a label detection or a shot change detection. And that'll kick off an operation. And one thing you can also pass into your request is an output URL for the JSON to be sent in Cloud Storage. So if you want to store the annotation JSON in Cloud Storage, you can just pass that URL into your request. And then when the video API is done processing, it'll write it to Cloud Storage.
Oh, nice.
If you want that's a really useful feature. I actually used that for the demo that I built. If you want the annotations right away, all you need to do is just ping the operation ID and see what the status is. It'll give you a progress on how far along it is. And once it's done, it'll return the annotations to you.
I think that would be a neat way of like integrating with Firebase storage as well.
Definitely. I didn't use Firebase for this, but I used Cloud Functions to build the demo. So what I did was I had a Google Cloud Storage bucket that had all my videos, and I had a Cloud Function listening on that bucket. So whenever a new file was added, it checked, is it a video file? If it was, it would send it to the API. And because I didn't need the annotations right away, I just had it output the results to a separate Cloud Storage bucket with the annotation JSON. And then I used Node on App Engine for the front end. So I just wasn't calling the video API directly from the App Engine app. All it did was grab all the videos from the Cloud Storage bucket and then their associated metadata from the other bucket.
Nice. So this gave me 2 questions. The first one is that code open source?
That's a good question. The answer is yes, hopefully soon.
Good.
I'm starting on that process this week.
Okay,
so
awesome.
Once the code is open source, I'm hoping to do a blog post about it, and I'll give you a link to add to the show notes as well.
Perfect.
Excellent. I expect by the time this comes out, you should have it done.
Nice.
Yes, that's the goal.
And the second question is, how fast is this? Like you said that you can give the URL for a YouTube video, let's say like for a video in Google Cloud Storage. Let's say that the video is like 1 minute. How long should I expect this to take? Like seconds, microseconds, minutes, hours?
Right now, it takes about a fourth of the time of the video. So for your 1 minute video, it would take about 15 seconds to run the annotations, which is actually pretty fast. So it's not real time, but you can get the annotation results pretty fast. What would take a while is if you had a large library of videos, maybe terabytes of videos, it could take a matter of days to process. But right now, I've seen it about a fourth the length of the video.
Nice. No, I was considering it because if you want to build a demo that is pretty, like it feels snappy, then you could actually make it. Like if you have a video that is like around 10 seconds, then it's going to take 1 or 2 seconds to process. That is awesome.
Exactly, yeah.
And what about, and probably you're going to tell me that the answer is no, or this is top secret, but is there any way of doing video streaming and getting streaming on like labels and stuff like that? Is this something that anyone has asked, or I'm just crazy?
Oh, do you mean getting the labels from your video as it comes in, or through a real-time video stream?
Actually, having the input to the API being a real video stream and getting a stream of of notifications or JSON containing the current label for the current piece that is being processed or something like that. I don't know, maybe it's crazy.
I don't think it's crazy. It's actually a great idea. That is not supported right now, but I can pass the feedback along to the right people. And it's interesting you bring up streaming because our speech API does that.
Yeah, exactly.
It supports either batch or streaming mode. So you can send it a complete audio file in cloud storage, or you can send it a stream of audio, and as the API transcribes it, it'll give you the results.
Cool. Well, I guess people are just going to have to wait and see. All right, sweet. So if people want to get started playing with the Video Intelligence API, how can they do that?
They can go to cloud.google.com/video-intelligence, and they need to fill out a form to sign up for the private beta. It's in private beta right now. So just fill out that form, and then you should receive a notification soon after that. And I would love to hear anybody's feedback on it that's part of the private beta, trying it out. They can find me on Twitter, @SRobTweets. You can put it in the show notes as well.
Yeah, we will. It's still private beta, so I'm sure you have not seen many projects, but what is the coolest usage you've seen of this API?
I've seen some cool visualizations of how people are displaying the labels from their video. So the main use cases I've seen for customers are Cantemo and Wix, which I mentioned before. But I've seen some cool integrations with D3 because you get pretty granular label data from every scene in your video. We used a little bit of D3 in the demo, but I've seen some interesting like line graphs to show how the labels and objects are changing as you move throughout a video. And I'm definitely excited to see what else people build with it.
Nice. I'm gonna definitely play with it. It's like lots of fun.
Yeah.
It's a ton of fun.
We're kind of running out of time, but is there anything else that you'd like to add?
I think I covered pretty much everything. I'm really excited to see where this goes and what else people do with it.
Excellent. Well, Sara, thank you so much for joining us. Always a pleasure to have you on the podcast.
Thank you for having me.
Thank you.
I'm always super happy when members of our team get to pop by on the podcast. Sara, no exception there. Thank you so much for joining us. to come talk to us about the Video Intelligence API. We should make a mention. Sarah talked about it a bit when we interviewed her. There is an open source version of the code that she showed in the demo. It's available up on GitHub, so we'll make sure there's a link to that in the show notes.
This is actually a very advanced technology. Like if you told me 5 years ago, you just give a video and it describes it, I'd be like, yeah, sure, whatever.
Yeah, exactly.
So the fact that now you can do that with a JSON API, like that is pretty amazing. So
JSON powers the internet.
Yeah. So hopefully people will go and check out that repo on GitHub and try to modify it and do some cool things with it. I hope that we'll see some amazing demos derived from this one.
Excellent. All right, why don't we get stuck into our question of the week? So the situation is thusly. Say I've got one or more virtual machines. They have some data on them and some sort of application running on them as well. And say the data on those is going to change. Like the classic example, which people don't do probably as much anymore, is something like an FTP server or something similar. That kind of scenario. What are my options or the best practices I should use for making sure that data is backed up? Because I want to make sure that if something bad happens to that VM or the disk gets corrupted in some crazy way, which shouldn't happen, but who knows, what can I use to make sure that I can recover from that relatively quickly?
Yeah, so the question comes from FRWillia23. Free Willy, maybe? I don't know. I think that it is pretty interesting because you were saying in case the disk gets some corruption or something, that will never happen. But your software could have a bug, right? So you could somehow like wipe all the data in your hard disk. This is something that happens, and this is something that I've personally done. It is not fun. So you want to make sure that you keep copies. And the question has a very obvious answer, which is, just use disk snapshots, because they're really made for that, right? I thought that was probably the only answer, but we also started chatting about, well, could we do the same thing with Google Cloud Storage, right? Especially because Google Cloud Storage, you have nearline and coldline, which are classes of storage that allow you to store the same data with same durability, but with less. Basically, it takes a little bit longer to access, but it's way cheaper. So we're wondering, it's probably the best solution. Turns out that it is not, because if you're running snapshots, the price for snapshots or nearline is the same, exactly the same. And with coldline, you could go a little bit cheaper, but then you have the problem that for nearline or coldline, creating a snapshot from that data is not as simple as creating a snapshot from a snapshot. Because when you have a snapshot, everything you need to do if you want to create a new disk, it's just one click and you're done, or one REST API or one gcloud command. So it is way simpler. And unless you had a huge amount of data that you were storing in, like you were backing up, and then in that case, as you were mentioning, like maybe you should not be using persistent disks. So unless you're using a huge amount of data on persistent disks, and that little difference in price makes a lot of difference, I'd say that you should just simply use snapshots, because once the price is it's actually the same as nearline, and they're much easier to use.
Yeah, it's worth noting that snapshots, they're diff-based. So you don't have to grab the whole thing again, which you might necessarily need to do if you're going to shift all your stuff over to some sort of cloud storage instance.
Yeah.
What's also kind of cool about them is that snapshots are globally available. So if you want to restore them, you can restore them to any zone within your project. So that makes them super, super useful, especially if you want to capture your operating system as well as your data at the same time. So your recovery time is pretty sweet.
I think in that case, it's important to take into account that when you have a snapshot and you're copying it across networks, across regions, there's a fee associated to that, because you're actually transferring data across networks. So there's like ingress and egress and stuff like that that you take into account. Very related to that, if you store that information into cloud storage, into nearline or coldline, you also have a cost associated to reading all that data. So we'll have a bunch of links in the show notes. There's actually a very good article that we found while doing the research for this question, which the name is Designing a Disaster Recovery Plan. And it covers instant snapshots, but way more than that. So maybe even a good topic for for an episode. I don't know who would be the good person to have, but like, what do we do when things go wrong? Not internally, that'd be SRE, but if you're a customer, what are the kind of things that you can do to prepare for any mistakes that could happen in your production?
I like that idea a lot. We should do that.
Cool. So I think that with that, the question has been answered. So thank you, FRWillia23, for that great question. I hope that you'll be happy with the answer.
Excellent. All right. Well, Francesc, I know you just got back from China, but what are you up to lately?
Bunch of things. I'm going to be in New York next week, and I'll actually be on Monday. I'll be presenting at the Google Developer Group in New York City with Brett. He'll be talking about cloud functions, and I'll be doing a couple demos on cloud endpoints. And after that, my next trip is something that I did not expect, but I will be going to Buenos Aires in Argentina.
Oh, nice. What are you doing there?
I will be going to an event that I'm not sure it's already public, but it's like a Google event that's going to happen there. But I will make sure to get a couple extra days so I can run some meetups.
Very cool. Very, very cool.
What about you?
So we will be hosting the Extra Life and Playcrafting Game Jam here in San Francisco. I'll be around for that. So if you're in the area and you want to raise some money for kids in hospitals, please come by. A couple of weeks after that, I will be up at the Nordic Game Conference in Malmo, Sweden. I'm probably mispronouncing that terribly.
I think you're pronouncing it correctly. It's Malmo.
Really?
Yeah.
Malmo? Okay.
I'm pretty sure, yeah.
Wow. I usually mess that up entirely. But yeah, I think that's the stuff that I've been doing. I do have a blog post that I just put live. I know I've mentioned on the podcast a couple of times talking about running game servers on Kubernetes. I just put the first part of a series up live. So I'll put a link to that in the show notes as well.
Nice. And since you're mentioning that, I'll also mention my Just for Fun video that I released 4 days ago. So that's pretty new. The previous episode was on the context package and how to use it. This one is on how to implement it. So if you're interested in seeing me hack stuff in Go, go check it out. We have a link in the show notes too.
Excellent. Well, Francesc, thank you again for spending time with me and doing another podcast.
Thank you, Mark, and thank you all for listening.
See you all next week.